This is my research presentation solving for G gap in graphs using GeoGebra, the effectiveness of GeoGebra in teaching graph competency for grade 11 senior high school. Context and rationale. So, solving for G gap in graphs using GeoGebra is an innovation of teaching instruction for grade 11 students which will focus on utilization of math software known as GeoGebra. So, we believe that this is a very useful way in helping our student in order for them to learn graph competency in core subjects such as general mathematics. We come up with this idea because graph competency is considered one of the most difficult competency in the course guide. So it was evidenced in our MPS. That's why we come up with an idea to integrate technology in the subject. And 4G is a contemporary word which relates to modern technology of communication like the modern connection of internet. The education as well as the teacher should find an easier way to connect with their students. And next, so we have the following research questions. Is there a significant difference between pre-test of Group A and Group B? Is there a significant difference between the post-test of Group A and Group B? And then what are the plan of action program proposed to help enhance the students' performance in mathematics core subjects? And here, so we have the following innovation, intervention, and strategy. So the role of the GeoGebra here is to make the rational function tangible. So here we pick an specific topic, rational function. So this is one of the competency of the core subject, general mathematics. So here we use GeoGebra to in order for our student to manipulate the values such as asymptotes and intercepts. So the process is like this one. Process 1 is teaching the content, process 2 is manipulation of GeoGebra, and process 3 is reinforcement of the learning through activity sheets. And next is the scope and limitation. So here we included only 37 participants from grade 11 students of Bagbag National High School, school year 2019-2020. And the methods are like this one. So we're going to identify the rational parts of the given GeoGebra generated graphs. Then B, computation of rational parts given function. And then C, illustration of rational graph given the function. And next we have pre-test. Then we'll subject to statistical analysis to test if there is a significant difference among the respondents before intervention program, as well as with the post-test in order for us to identify whether there's an improvement after the intervention. And the statistical analysis that we use here is t-test for independent samples because the two groups, controlled and experimental, they are independent from one another. That's why it is advisable to use the t-test for independent samples. Here, if the mean of the two groups is different, therefore, we can conclude that the intervention is effective. And here we utilize a 0.05 level of significance as the basis for rejecting hypothesis, p-value method. And we have the following results. The first results is that we failed to reject the null hypothesis with a p-value of 0.923. Here we can conclude that the two groups have no initial idea about the concept of function and graphs, which is ideal for the study. So here, the two groups have the same mean in terms of their pre-test. And next, after the intervention, we conclude that there is a significant difference after the intervention. So it is shown by the p-value significant testing using post-test. And what are the action plans? So we have the following action plan here. So since it is useful, so we would like to come up with an idea that to bring it down to the grade 7 level, the researcher needed indeed suggest to conduct the same intervention in lower grades of junior high school, since the competency of graph is utilized earlier before senior high school. And that's all of my presentation. Thank you.